Hello everyone and welcome to today's webinar, Practical Performance Profiling, presented to you by Jean-Philippe Guigou. So before we start, as I mentioned, today's main presenter is Jean-Philippe Guigou. Jean-Philippe is a Microsoft MVP with over 10 years experience in .NET, and I'm really pleased that he's managed to find a gap between his day job as a software architect and his university lecturing to spend some time with us today. Then you have me, Michaela Murray, aka Miss .NET. I am a product marketing specialist within the .NET division at Redgate Software. You can find me on Twitter at Miss.NET or on my blog on simpletalk.com. And finally, we have Chris Allen. Chris is a support engineer at Redgate Software as well. And again, he has over 10 years experience, and Chris will be joining us for the Q&A at the end of the webinar. So before we start, you will all be on mute for the duration of the webinar. We've got quite a lot of you here today, and I think it could get a bit chaotic if everyone was speaking at once. If you do have any questions as you go, then please do feel free to type them into the question pane on the control panel. If you have any problems with audio or you can't hear us, then just check your GoToWebinar audio settings first, and if there's still issues, then type a message into the chat box and we'll see if we can resolve that for you. And we are recording this webinar, so it will be available online in due course. Okay, so today's agenda, we're going to kick off with a quick poll, and then I'll do a very quick introduction to Redgate Software and hand over to Jean-Philippe Guigou for his main presentation and demonstration, and then we'll finish up with some Q&A and then the contact details of all of today's presenters. Okay, so let's kick off the poll. Okay, so you should all see a question on screen now asking how much .NET development experience you have. So this is just a quick question to help us gauge what sort of audience we've got here today, for Jean-Philippe to understand what type of people he has listening. We just thought it would be something that would be quite interesting to test. So whilst you're filling that out, I'll do a quick intro to Redgate. So if you aren't familiar with Redgate, or more specifically the .NET division at Redgate, we provide tools for .NET developers. So firstly, we have a product called Ant's Performance Profiler, which is a .NET code profiler used to identify performance bottlenecks. Ant's Memory Profiler, quite similar, used to optimize memory usage on .NET and spot any memory leaks. Smart Assembly is a .NET obfuscator tool, and Reflector, which is used to browse, analyze, decompile, and debug .NET code. That's all I'm going to say about Redgate today. I'm quite keen to hand over to Jean-Philippe for the main presentation, but if you do want to check out any of our products or the company, then there is a link at the bottom of the page. So let's take a look at the poll results. I think the majority of you have been developing in .NET for 5 years or more. A few of you are new to .NET, and the second highest ranking is that you've been developing between 1 and 3 years. So thanks for taking the time to do that. And I will hand over to Jean-Philippe now. So just bear with us. Sometimes the transition can be slow. Okay, Jean-Philippe, do you now have control?
No, I think you've got to close the poll before enabling the screen sharing, Michaela.
Okay, 1 second. Sorry about this, guys. Okay, we should be good to go now. Jean-Philippe, are you all set? Jean-Philippe, are you there?
Yeah, I didn't have the screen sharing. Do you have my slides?
Yeah, I have your slides.
Okay, thanks, Michaela, then.
Thank you.
Welcome, everybody, to this webinar. I'm really happy to see that there are so many people. I see we've got 72 attendees, Honestly, I was thinking that will be 20 or 30, but that's a good indicator that performance profiling is starting to get recognized as an important part of the software edition process. This makes me quite happy because I've been preaching for performance for almost a decade in .NET, and seeing that it interests more and more people is really good. Before we dive into Visual Studio and Ants Performance Profiler, let me just give you a bit of background. As Michael has said, I'm software architect. I'm working for a small company in software editing in France. And as the software architect of this company, I've done quite a lot of code reviews and code audits for the past 10 years, which were mainly oriented around security and performance. So this taught me a few things. So I saw patterns in the performance profiling and some tricks about profiling, and I wanted to share them, which is the reason why I wrote some books about the subject. The first one was in French at the editions called Any, and the second one was in English at Simple Talk edition with Redgate. The most important thing I've learned during these years of performance studying is that performance profiling really is not an expert issue. Most of the time people confuse performance profiling with tuning, and tuning actually is an expert issue. It's quite difficult. You've got to have long expertise to be able to tune finely an application to reach this last few % of performance. But profiling is not about tuning. Profiling is really getting rid of the big bottlenecks that you have way before tuning. And the second thing that makes it quite easy is that you've got software to help you for that. It's possible to automate the review of an application for performance. And even more, you have patterns in profiling. So exactly like you have patterns in object-oriented programming that helps you write some good code, you have patterns in profiling that helps you profile quickly the main bottlenecks of your application. Most of the time, it happens that a great part of the time lost in your application is only coming from a few performance problems. So I generally use this range that 80% of the time lost is coming from for the 20% of bugs about performance you have in an application. I've analyzed a dozen best practices that you can have in profiling, and today we'll be seeing only 3 of them because of lack of time. We only have 1 hour, but I try to have as broad a scope as possible. So we'll see some client-side profiling, we'll see a server-side profiling, and I'll end up this presentation with a classic issue of performance problem in .NET. What I want to show you during this 3 presentation is some trick about how to spot the patterns using Ants Performance Profiler. So we'll be using the performance counters, the call graph, different tools that you have in Ants Performance Profiler, and I try to show you how you can use these particular patterns I'm talking about to quickly reach the bottlenecks in your application. Okay, the demonstration will be done using Ants Performance Profiler in version 7.0, which was out a month ago or so. There may be a 7.1 now or coming. And the demonstration will be done using a virtual machine. That's something you should not do when profiling in production, because it goes against the environment neutrality, which is one of the 5 rules I've proposed in the book for efficient profiling. The reason why I'm doing this today is that my personal computer is in French, and I wanted the webinar to be with an English operating system and English Visual Studio. And also, the problem with the virtual machine is that it doesn't have a hardware clock. So the time that you get when doing a profiling analysis are not as stable as the ones you have with a hardware machine. So generally you should not using for profiling, at least when you want to compare different scenarios. But since this is just a demonstration and not an actual profiling session, that's not really a problem. The sample application I'm going to use today is coming from the book. This uses an actual architecture of a real-world application. So, of course, for copyright reasons, you will not see the actual screens and the actual code of the application. But Profi is a kind of potpourri of all the bad practices I've seen in the 10 years I've been working for the company I work for at the moment. I've been doing the architecture for this application. I've been doing a lot of code audits. We have between 30 and 40 developers on this application. And what I've decided to do is to create an application where I just put all the performance problem I had in the past 10 years, all the classical issues. So of course this is an absolutely ugly application. Please don't take the code for what it is not. Okay, so I'm going to switch to this virtual machine. And I'm going to show you quickly the application I'm talking about. Just a small demonstration for now, so you can see the business it addresses. We have a connection. For demonstration reason, the password is simply the reverse of the username. And what Profi does is that it dynamically loads different domains, different business domains. In our case, we've got a person's domain, we've got a contract domain. When loading the persons, I get the list of the persons in my database. I can see the details of one person, first name, last name, and description. And from this person, I can go to the list of contracts of the selected person. Same thing, I can select contract, see the details, and this time I've got some additional links. I can see a Word document that has been merge generated, and I can see a contract summary, which is just an XML with the details of the contract. And this is all we're going to see for this demonstration. The first way I could start profiling the application, when you install ANS Performance Profiler, you will have an additional menu in your Visual Studio, and I could just go here and click on Profile Performance. This is not going to change much. This is just going to run my application in debug mode, but this time it's going to do so under the control of ANS Performance Profiler. So you see ANS Performance Profiler firing up. And when ANS is ready, it's going to start the application. And again, I'm logging into the application, and I could do the exact same scenario as I've done before. So loading the persons, choosing one, getting the details, seeing the description of a person, seeing the list of contracts that are associated to it, getting the details, seeing the merge document, etc. When I close the application, ANS Performance Profiler is detecting that I'm done with my profiling scenario, and it gives me an analysis of the actual results. We could very well profile the application this way. It is possible to select some parts of the application. For example, we could see here that we've got a peak in CPU, so that's something we could take a look at. And in addition, we have this blue bars right here and orange bars that helps us to see what part of the user interaction we're in. So this is when the portal was activated. This is when the long test display was activated. This is the click on the button details, etc., etc. We could very well use this, but in general, it's quite interesting to be able to compare times. The thing is here, if we compare the actual clock time of the application, the times depend on the speed with which I click on the button. So this is generally not something I do when profiling a client. It's better to automate the scenario. One way to automate the scenario would be, for example, to use some specific software like Test Complete or Test Lab Management. What I'm going to show you today is what I call the poor man's automation. You do it just in C# code. For example, I could automate the login by simply associating to the activated event of the login form a delegate which specifies the text, send the password inside the secured password, which is a secured string, and closes the form with a dialog result OK. So this is what I'm going to do in all of the assemblies that are dynamically loaded by Profi. I'm just going to use this conditional compilation symbols test1, which is my first scenario. This is a scenario that's only based on the persons for now. And I'm using also the auto exit conditional compilation symbol, which, as the name states, is going to simply exit automatically from the application once the scenario is over. So this time I can run again my profiler for performance. And I'm not going to have to do any user interaction to get the whole scenario done and analyzed by Ants Performance Profiler. Because of screen sharing, you may not see the windows flashing, but some windows are flashing quite quickly to show that the scenario is going up. And anyway, we see the actual results. And this time, we see that the whole scenario has been done in around 8 seconds. So this time, every time we're going to improve the application, we'll be able to compare the actual time with the version that was not improved before improvement. That's a good step already. Okay, now I'm going to show you one of the first patterns I was talking about. This pattern is what I call the high exception frequency, or the high exception rate in functions. Sorry. In our case, the first thing that Ants Performance Profiler is analyzing is that it's showing what is called the hot pass. One of the main rules in performance profiling is that you should always take care of the longest time in actions in your scenario. The reason is that it's sometimes very easy to spot some place where you can have a performance improvement. You may see some code that you know how to improve, but if this code amounts for only 1% of the time spent in your scenario, improving it even by twice or 3 times is not going to help. It's just going to save you a few seconds. So the most important when profiling is to start with the biggest time. And this is what the profiler helps you with by displaying this hot pass here. It's the stack that takes most of the time of your scenario. And in particular here, we see that we've got this load components method, which takes the major part of the main method. This is the methods that load dynamically the components. I told you that the sample application I'm using is dynamically loading the different business models, and this is the function that does it. So we're going to take a look at what's going on inside this load components, where normally we should analyze what's going on to initialize and the service contract constructor. I'm not going to do this for this demonstration because this particular method is quite difficult to debug and see through the performance problem. I'm just going here to change to any method so that we can see the other methods that are inside the hot pass. And you see that the second one inside the hot pass is this load from assembly. The pattern I want to show you is that when inside load component here, when you select a method, Ants Performance Profiler is helping you by putting it in green here. And we see that we've got quite a lot of exceptions. Exceptions are marked with the red bars right here, and we see that we've got quite a high rate of exception. Normally, in a scenario, exceptions should remain, well, exceptional. That's why we call them this way. And this is not normal that inside one particular function you've got several exceptions coming in a row. And what happens here, if we take a look at the origin of the exception, is that they're coming from load from. When in load component, we see that we are looping on all of the files in the executable assembly directory, and for each of these files we're trying to load them into an assembly, into a .NET assembly. But if we take a look at the executing directory, those are the files that we've got in here. We've got 15 files here, so we see that we've got a 15 hit count in Ants Performance Profiler, so it's the right correspondence. And what we're doing badly is that all these files, all these PDB files for debug, all these config files, there are no way that they're going to load into a .NET assembly because they're not .dls or .exe. So this is why we have exceptions. The correction for that would be to go into the load component, and for example what we could do is when we've got this assembly file, we could get the file information from the assembly file, and what we could do is saying, okay, if we compare the extension from this file with .dll, and we're going to do so ignoring the case, and if this file is not a DLL, well, we should just not load it, and we should just go to the next file. If I run the application this way, and this is why it's so important to have an automated test in your application, we see nothing in the portal. And this is because even the executable is dynamically loaded for display classes in Profi. So executing just a quick test is very important. This is what I wanted to show you. I could have started straight away from here with the new performance profiling, and it would tell me that the application goes way quicker. But of course, because it wouldn't do anything. So it is very important to have a complete automated test, and if possible, put asserts in your application. So the actual correction here would be rather to say we take the DLL and also the executable. Again, I can now run my application and I see that the whole scenario has been done automatically. So this time I'm going to profile performance again, and I'm going to check inside the profiler that I reached the results I wanted to. Again, Ants is starting the application with the automated scenario, and it shows me the result. If I check the hit count for assembly load from, we only have 6 in here, and the load components now is a bit quicker. It doesn't change much. It doesn't change by a few seconds or so, but we're on a very small scenario, and gaining 5 or 10% is already very, very good results. So that was the first pattern I wanted to show you, this high exception rate in here. You see that we've got some more exception because I've not gone to the end of it. We could also add some more restriction because normally we should only use the Profi assembly and not the external assemblies, etc., etc. This was an example of client profiling and an example of pattern, which was the high exception rate in a function. Now we're going to change a bit the way we profile. I'm going first to change the scenario I'm doing. This time I'm not going to do a scenario about persons. I'm going to do a scenario where I load all the possible contracts. So this one is taking quite a lot of time because there is a big performance issue in the code, and I'm loading all the 102 contracts in the application. Instead of profiling the performance of the client, I'm now going to launch Ant Performance Profiler. And since I don't run an application, it's going to ask me what kind of settings, what kind of profiling session I want to get. I'm going to do an ASP.NET Web Application profiling session, and in particular, in this case, I'm using the web development server. I'm using the Cassini and not IIS. I'm pointing the ASP.NET Web Application to one of the ASMX I've got in my virtual directory from Cassini. And the important thing here is that I'm going to take note of this port that I've got to bind. And I'm going to change the client so that I bind to this port. When I start profiling, I've got this user account control message, which is normal because Ant Performance Profiler needs some elevated privileges to do so, to do its analysis. And the way the profiler is helping me to profile a server is simply, for now, by providing an internet browser pointing to localhost with the port number for the under control of the profiler. So I'm going to use this same port number, but in my automated application. And instead of going on my normal Cassini, I'm just going to reach localhost 8013. And I'm going to execute the second scenario, the second automated scenario in here. This one is a bit longer. You'll see that it spans almost 10 seconds to retrieve the contract because there is a big performance issue in there. I'm not touching anything at the moment because this scenario is also handling some merged document, and the automated scenario is based on the focus of the windows, so you should never change focus during the time of the scenario. Okay, the scenario has been done, so I can stop profiling right here from Ant Performance Profiler. And this first part I had at the beginning was when I started the server. What I'm interested in is the second part. This is my automated scenario from the server. I'm going to go back to methods with source because I'm mostly interested with the methods for which I have the control. And again, the good thing to do is always start with the hot pass. So we see that the hot pass here is apparently a service. It's a web service called retrieve contracts list. And in particular, we see that this retrieve contract from cursor here is a function that's called 102 times inside contract retrieve list. So this is the second pattern I want to show you. Generally speaking, when you profile the performance of an application, you may have loops, which is absolutely normal because what we want from a computer is doing simple tasks in an iteration. You may have also some functions that are complicated from the business point of view. It happens that sometimes you need a lot of calculation. But of course, for performance reason, you should never cross both. That means if you have business methods that need quite some analysis and take some time, you should never do them in a loop. You should always restrict your data or restrict your processing before passing it into the loop. And one way to spot this kind of problem, which is basically how to spot a loop that has got a problem of performance in a performance profiler, is to take a look at the range of data here. So when you take a look at the time with children, you see that between retrieve list and retrieve contract from cursor, we don't have much change. Here we're at 17.359 and here we're at 17.351. But the hit count has changed dramatically. So when you see this particular pattern when you've got almost the same time in here and in the parent function and the hit count has changed, this means that you're inside a function that is doing a loop over a function that is not quick enough to be used normally in a loop, or at least without performance issue. So you've got two different ways to solve this problem. In our case here, what happens is that I retrieve all the contracts from the database, which is normal. I want the contract list. But what I'm doing bad is that I'm merging the contract document on each of the contracts. And this is bad because the first scenario I showed you, if you remember, was to take a look at the list of contracts, but I only watched the merge document for one of the contracts. So merging the contract before even knowing that the user is going to look at the merge document is really the worst practice you can have. This is the reason why this function here is so slow. And when you get rid of merge contract document and extract reference contract to directory, which is basically unzipping the Microsoft Word template, you realize that you spend almost no time in this function here. If we take a look at this retrieve contract from cursor and use the call graph, we're seeing that merge contract document and extract reference take more than almost 94% of the function retrieve contract from cursor. So if this method is called in a list, this is not something you should do. So you've got two ways to solve the problem. When you have a loop over a function that is quite slow, either you make a smaller loop, so that basically means restricting your data before passing it through the process. So that's typically putting some additional wear on the database, etc. Or you can stream the data also. Or the second solution is to get a quicker response from the function. And this is what we would do here simply by getting rid of merge document and extract reference. Again, I'm not going to show you the correction in the code. That's not the interesting bit. The interesting bit really here is to be able to spot these patterns when you see that you have quite the same amount in here, but the hit count is changing dramatically. That's the second pattern I wanted to show you. I'll finish with a third profiling pattern. If we get rid of this hot pass here, the second hot pass, so basically the second thing we should analyze in a row we should work in a sequence when profiling, starting from the hottest path, then the second hottest, etc. So the second thing that we would take care of once the first one is solved is this retrieve server setting. It's again a web service, and in particular we see that we spend quite a lot of time inside this remove separators. If we take a look again at the call graph, we see that we've got a very odd distribution of the methods that are called by remove separator. What I call an odd distribution is it's a pattern I've learned to use, because when methods start to get more and more analyzed and refined, and they don't have performance issues anymore, you realize that the distribution of time inside the child functions is quite even. You are going to spend 20% in one, 30% in the other, etc. But when you spot function in which one of the method is taking more than half the time of the function, well, you should really take a look at what's going on in there. And if we take a look in this string concatenation, we see that the hit count is huge. We've got 2,000 calls to remove separators, but the hit count of string concatenation is not 2,000, it's more than 1 million, almost 1 million point 2. And as you certainly know, because we seem to have quite an expert audience with lots of people having more than 5 years of .NET, you should never use string concatenation for a large number of concats. This is why you have a string builder for. So the correction in here will be to simply replace this remove separator with a string builder right here, instead of using the string concatenation operator. We would use the append function, and at the end we will call the toString on the result. Again, I'm not going to show you all the profiling. This is not the important bit. The important bit was to show you this pattern. When you have an odd distribution of function right here, you should take a look at what's going on, and in particular the hit count of the secondary function. I'm just showing you this. This is quite interesting. Most of the time, N's performance profiler is going to hide the insignificant method, which is very good because it helps you seeing through all the methods and not getting disturbed with functions that have got a very small weight in there. So I'm just going to go back to the slides now and make a little summary of what we have seen during this presentation. The first pattern I wanted to show you was this high exception rate. When you spot one particular method inside your scenario and you see that you've got exceptions quite close to the other and that seem to appear in a loop, this is something you should take care of. Exceptions are extremely, can be a very big problem when they're in loop in .NET, because generally speaking, an exception is going to take around 1,000 times the time of a single test. So you should only have exceptions for exceptional reasons. The second pattern I showed you is this dramatic change in the hit count when the time remains stable between a parent function and the children function. Finally, the third pattern was this odd methods distribution in the call graph. Again, it's not a rule, it's really a best practice. When you have a function inside a parent function that takes more than half the time, you should really take care of what's going on inside this function. I'm just going to yes, we've got a bit of time. Just going to give you one last pattern. It's a pattern about the garbage collector. You certainly know that in .NET we've got a garbage collector which is using generations, and most of the time the performance, it's difficult to oppose performance profiling and memory profiling. Most of the time people take them separately, but in fact it's very close one to the other. A lot of performance problems in .NET come from the fact that there is a memory issue in the garbage collector. So generally that's because you generate many instances for a short lifetime, so you're giving a lot of work to the garbage collector, or your code is done in such a way that these instances will go very quickly into the higher generations. This is the reason why we advise to never use manually the GC collect API. So this pattern I wanted to talk to you is it's a pattern of the ratio, about the ratio of generations in the garbage collector. Generally speaking, when you observe a pattern of one full collection for 10 generation 1 collection for 1000 generation 0 collection, you're in the right ratio for an efficient garbage collection. When you see that this ratio reaches 1 to 10 to 10, or in the worst case 1 to 1 to 1, you have a huge problem of garbage collection, and generally you should try to find why your instances are going directly into the second generation. This is something that should only happen for 1/1000th of the object. Finally, if we've got to round this up to a few basic rules, I would say that most of the classical performance issues you have are related to three basic things. It's when you have low control over iterations first, so that's the main performance issue. You'll always have loops in computer programs. That's what computers are for, looping over small and dumb functions. But you have to have a good control over the iteration. Generally speaking, when writing your functions, you should always have quite a good idea of how many iterations of the loop you can handle by keeping good performance. Another classical issue is when developers have not the control of the lifetime of a variable. The typical issue is, for example, putting a variable as a member instead of putting it as a local variable, because in this case that means that the instance that is associated to the variable is going to have the lifetime of the application and not the lifetime of the only focus of code that you have. So you're increasing the lifetime of a variable, so that means you add some memory pressure, you add some work to the garbage collector, because it's going to have to put your instance into generation 1 and then in generation 2. So generally speaking, try to have the shortest lifetime for all your variables. When you're done with an instance, put the variable that was referencing it to null. Same thing, do not create the variable as too early. So those are concepts that are called as early release and late instantiation. And just like for other patterns, I recommend you to read a book or read some material on the internet about this. And the third classical issue, but this one everybody knows this one, I guess, is using load instead of streaming. Of course, it's way easier to use an XML document than an XML stream reader. Of course, it's way easier to do a file.readAllText rather than using a stream reader. But when you run your application with higher loads, you're going to hit performance issue. Whereas if you use streaming, you're just going to grow the performance linearly. And the last point was that I was reduced in the time. We only have 1 hour for this presentation, so I showed you 3 of the patterns I thought were the most important for beginners. And you, of course, have got much more patterns and rules in the book. So, well, I guess we're back to Ms. Dotness and Chris for some questions and answers.
Thank you very much, JP. I'll just take the control back. Thank you for that. Okay. So our first question is, does Ants Performance Profiler support WPF? So I'm just going to hand over to Chris to answer that.
Thank you, Michaela. Yes, I can confidently say that Ants supports WPF. In fact, it will support any technology that is a .NET technology. You can even run a native code executable that subsequently calls the .NET framework, and Ants will automatically pick up on the loading of the .NET framework and profile every single .NET method. Even if that .NET process goes native and comes back again, Ants will just tell you every single .NET method that has gone on in your process.
Okay, thank you, Chris. I think it's probably just worth saying, if you do have any questions that you would like Chris or Jean-Philippe to answer, then please get them in now. In the meantime, I'll move on to our second question, which is, what's the difference between sampling profiling mode and line level mode? Chris, are you okay to take that one again?
Yes, no problem. Hopefully you can see this. I'm going to show you the options that you get when you initiate a profiling session. So you have quite a few options when it comes to initiating the session. We have tried our best to minimize all the decisions you have to make, and really this area here indicates the most important parameters to initiate your session. Of course, pointing towards your executable or your website, that's obviously important. A later feature recording the SQL and file I/O performance, also important. But the question relates to the options you get here. Breaking this down, there are 2 fundamental techniques of profiling, one of which is sampling technique, and the other, which is characterized by all the above, the other technique is called instrumentation, and this is where code is actually dynamically injected into your process, your application's process, which initiates all the timing metrics per method, per line. It's quite invasive. So the difference is very much a case of how much data you're getting from your process and how much you are affecting the process. Sampling is on one side of the scale, where it affects your program the least, but you get less detail, so it's fastest. It's also recommended in terms of accuracy. So what I would generally recommend is when you're starting your profiling work right from the start with sampling mode, because it will give you data quickly and actually a little bit more accurately. And all the above increase in detail, so you can finally, when you have focused on the bottleneck in your application, when you're confident of that, you can switch to line level mode and get the most detail about exactly what is causing the bottleneck. So start off here and end up here. Different techniques give you very different responses from your application.
Thanks, Chris. Okay.
In terms of production workflow, do you hear me, Michaela?
Yes, we can hear you.
Yeah. I just wanted to add that in terms of production workflow, generally what you're going to do is that you're going to use the sampling mode while manually during a scenario on the application, and when you analyze the specific part that you've got in the application that has got a performance issue, you're going to switch to line level, and in this case, what I generally do is that I create an automated unit test that is specific to the part of the scenario that we're interested in, and this is what I put into line level profiling. So you've got the best of the two.
Okay, so Jean-Philippe, Mitch has just said again, what are generation ratios? Can you expand on what generation ratios are a bit more?
Okay, so the garbage collector you have in .NET is what is called a generation-based garbage collector, which means that in order to improve performance, the garbage collector of .NET is not always going to run through all the memory to find the instances that are not referenced anymore. The reason why it does this is for performance reason, because most of the time, statistically, if the garbage collector has found that a particular variable cannot be collected at the first run, there are more chances that it's not going to be collected in the second run. So if we take the two extremes, on the first extreme, you've got a local variable that is just going to be used for perhaps 1 or 10 milliseconds. So the chances are very slow that the garbage collector is going to run during this time. And when the garbage collector is going to run, it's going to see that this local variable is not pointing anymore to the instance. So the instance will be able to be collected and the associated memory will be recycled. And if we take the other extreme is typically a static variable on a class that was loaded by the application. Once you have loaded this class in the application, it's just not going to disappear, and you're going to keep this static variable all the time in your application. It's always going to be accessible. So the first time the garbage collector is going to analyze this particular instance, it's going to see that it is referenced by a static variable, so it's not going to recycle it. But it's going to do one more thing. It's going to put it into generation 1, which means that the next time the garbage collector is going to go through a normal generation, it's just not going to study it anymore. And the garbage collector is going to do this for quite a lot of time. And when the garbage collector is going to have some pressure from the operating system to release some memory, it's going to start with what is called a generation 0 collection. So it's going to test all the variables, all the instances, that it has not taken into account first. And if this is not enough, if the collection of memory is not enough with a generation 0, this is when the garbage collector is going to go to what is called a generation 1 collection. And this time, it's going to try again to find if the instances that were put in generation 1 can be collected this time. And this is the same for generation 2. So when the garbage collector is doing a generation 1 collection, if it finds out that a particular instance cannot be collected, it's going to put it in generation 2. And basically what happens is that after a few passes of garbage collection, what goes into generation 2 is basically the instances that have got a very, very long lifetime, basically the lifetime of the complete application. So this is why normally you should not have a lot of memory inside there. You should have basically static variables and things like this. And this is why we should have a high ratio. It is important to have a high ratio between generation 2 size and generation 0 size. Generation 0 is when you have local variables, you have a quick use of these variables, they're inside a short focus, so you're going to have the most performance out of it. And most important, you're not going to overload the garbage collector with work. Because garbage collector, for example, if you force some local variables to go into generation 1 or generation 2, or if you call GC collect full generation in a loop, you'll see that the garbage collector is actually taking quite a lot of time. It can take up to 30% of the time in your application. So this is important not to stimulate it too much.
Okay, so Jean-Philippe, there's another question about mixed modes, and the question is, how far can the ANTS profiler step into unmanaged code?
As far as I know, ANTS Performance Profiler is not limited to is not able to go into unmanaged code, but Chris is certainly going to be able to tell us more about this. As far as I've done, I've only run into managed code.
Yes, that's correct. That ANTS will allow unmanaged code in your process, whether that your process starts off as native or ends up being native. ANTS doesn't have a problem with that, but it won't be able to give you any data about that. But naturally what you will have is the return time, the time it takes to go in and back again. You know, you can work that out from the method time. So you get the full stack time still, but you don't get any detail about what happened when it went native.
Okay, and the next question is, does ANTS Profiler add performance overhead while profiling? JP, do you want to?
Well, yes, of course it does, but if you carefully choose the profiling mode, and when you start with the sampling mode, honestly the overhead is almost nil. It's just going to be a few percent at maximum. So this is why it's so important to have a good programming workflow. When you profile an application, you should start when you don't know where the performance problem is coming from. You should start with the sampling profiling mode, which is not going to add any overhead. You should use this to restrict to the point where you have a performance problem. And then you're going to have a particular test that points to this issue, and there you're going to use the line level mode, which is going to add quite some overhead, but this is not important anymore because you are in the particular spot that you're exploring. When you're in line level mode, yeah, the overhead can be big. It can multiply the time of the scenario by 2 sometimes, but it doesn't really matter because if you use carefully the profiling modes, when you're in sampling mode, you have a scenario that it's a few seconds only.
Okay, yeah. I think it's just worth saying as well, with sitting with the development team for the ANTS Performance Profiler, I know that it's something that they work hard on to keep as minimal as they can. Okay, so I think that's all we've got time for today. If we haven't got round to answering your question, then Jean-Philippe's contact details are on screen, as well as myself and Chris. So please feel free to email any questions that you might have over. There's just a few useful links that would be worth sharing with you. So if you want to have a go at doing some profiling yourself, then feel free to download a free trial of ANTS Performance Profiler. And again, with everything that you need to know about profiling, Jean-Philippe's book is now available for free as well. You can use the link that's on the screen now. And as Jean-Philippe said earlier, a lot of the stuff that he hasn't even had a chance to cover today is covered in the book. So it would be well worth a read if performance is an area of interest to you. So thank you very much, Jean-Philippe. Thanks for your time.
Thank you. Thank you, everybody, for listening.
Thank you. Bye-bye.
Bye all.